Friends, very good morning to everyone. Today's subject of discussion is cycloalkanes. These are also called as cycloparaffins. This, as the name indicates, these are the brothers of alkanes. Alkanes, as we know, the most rugged species, the most unreactive species, the most laziest species, which do not react at all. Right. Today's subject of discussion is cycloalkanes, the brothers of alkanes. Cycloalkanes belongs to the class of alicyclic compounds. As the name indicates, ali stands for aliphatic, cyclic stands for cyclic compounds. These are aliphatic compounds which are cyclic in nature. As they are aliphatic compounds similar to that of alkanes, as I said, they are the brothers of alkanes, their properties should be similar to alkane. They have saturated carbons. They come under the class of saturated hydrocarbons. They do not contain any pi bonds. Their valency is satisfied with sigma bonds only, like that of alkane. They have the general formula CnH2n. The first member of the series is cyclopropane with molecular formula C3H6. The carbon and hydrogen is in 1:2 ratio like that of alkenes. Hence, they are called as functional isomers of alkenes. If I take this compound, this is 2-butene with a molecular formula C4H8. This molecule is 1-butene, which also has a molecular formula C4H8. If I take this is cyclobutane, which is also having molecular formula C4H8. Means all cycloalkanes are functional isomers of alkenes. How to name the cycloalkanes? It's very simple. Like alkanes how we name, the same way we name. But we are adding the prefix cyclo. We add the prefix cyclo to alkane, it becomes cycloalkane. If I take this molecule having 3 carbons, that's why it should be propane. As it is cyclic, I add prefix cyclo, that's why it is cyclopropane. Similarly, cyclobutane. This has 4 carbons and it is cyclic ring structure, hence it is cyclobutane. Has 5 carbons, that's why it is cyclopentane. These are 6 carbons in cyclic form, that's why it is cyclohexane. This is having 7 carbons, that's why it's cycloheptane. If they are substituted cycloalkanes, how should we name it? It follows the same procedure what we followed for alkanes or alkenes or any other hydrocarbons. Here, we number the ring system such that the substituent gets the lowest numbering. You see here, you number these systems such that the substituents gets the lowest number. I can number this as 1, 2, 3, 4 and 5. That's why it is cyclopentadiene. 1, 3 cyclopentadiene. Here it is having 5 membered ring. That's why it is cyclopentane, 1 double bond at 1 and 2 position. That's why cyclopent 1-ene. And at 3 position, we have ethyl group attached to it. That's why it is 3-ethyl cyclopent 1-ene. We have to number here like 1, 2, 3, 4, 5, 6. If I number in this fashion 1, 2, 3, 4, 5, the substituents will be 1 and 5. If I number in clockwise form, it is 1 and 3. That's why I have to number such that the substituents gets the lowest numbering. This is 1, 3 dimethyl cyclohexane. There are other set of cycloalkanes. They are bicyclic alkanes. As the name indicates, they have two cyclic ring structure in it. Bicyclic. This is named like this: bicyclo 2, 2, 1 heptane. How is this named? Bicyclo is here. What it indicates? It has two ring system. This part is one ring system. This part is another ring system. That's why it is bicyclic. That's why it is represented as bicyclo. If I cut two carbon bonds, I'll get a alkane with 7 carbons. That's why it is named as heptane. What is this 2 to 1 stands for? Here, this first 2 stands for C2 and C3. The 2-3 side of this bicyclic ring system, and another 2 stands for C5 and C6. The C5 and C6 side of the bicyclic ring system are separated by a bridged carbon having one carbon in it. 2, 2, 1 represents the C2, C3, C5, C6 carbon and C7 carbon. This is how it is named as bicyclo 2, 2, 1 heptane. Now let us name this. Here we name it as bicyclo, as it has two cyclic ring system, 2, 2, 2 octane. Here there are 8 carbons, that's why it is octane. This first 2 represent C2, C3 side of this bicyclic ring system. The second one represent the C5, C6 side of the bicyclic ring system, is separated by a bridge carbon having 2 carbons in it, C7 and C8. That's why 2, 2, 2 octane. How to synthesize this molecule? Cycloalkanes are prepared by dihalo compounds. I take 1, 3 dibromopropane and treat with sodium and heat it in the presence of ethanol. I'll get corresponding cyclic ring structure, cyclopropane. Now let us see how this reaction occurs. Here, when I treat with sodium, the Na combines with Br to give us NaBr. The Br minus goes away with Na plus and loses as sodium bromide. And here CH2 combines with another molecule of sodium and I'll get corresponding organometallic compound, sodium salt of the propyl bromide. When it is combined with sodium, a metal, it is more electron rich than carbon. It donates the electrons to carbon and makes this carbon electron rich. Hence, this is a carbene ion. Now, if I heat these electrons, attacks on this carbon. This is a positive center as it is attached to bromide. Once this minus combines with CH2 plus, the partially positive carbon, bromide has to maintain its tetravalency and bromide gets kicked off, and this bromide ion and Na plus ion combines to lose as sodium bromide, and the cyclization has occurred to give rise to cyclopropane. Similarly, if I take 1,4-dibromobutane and treat with sodium and the presence of ethanol, I'll get corresponding cyclobutane. We can also prepare not only from the dialkyl halides, we can prepare it from calcium or barium salts of dicarboxylic acids. It is a dicarboxylic acid. When we treat with heat, it undergoes cyclization to give rise to a cyclopentanone. Cyclopentanone, which is formed when I reduce it with a reducing agent like zinc and amalgam, I'll get cyclopentane. Similarly, we can prepare cycloalkanes by esters of dicarboxylic acid. This reaction of cyclization of dicarboxylic acid is called as Dickmann condensation. I take a dicarboxylate ester and treat with sodium ethoxide. As we know, sodium ethoxide is a strong base. Na plus OET minus. OET minus abstract the proton from this carbon. This carbon hydrogen is loosely bound because of the fact that this carbon is attached to a carbonyl group which is electronegative in nature, which pulls the electrons towards it, making this carbon positive. That's why as the positive means it indicates that carbon hydrogen bond is weak. With less amount of electrons, it is withholding the hydrogen. Hence, the bond between carbon and hydrogen is weak. Ethoxide, OET minus, abstract the proton, creating a carbene ion. The carbene ion which is formed attack on this carbonyl carbon and it has to maintain its tetravalency. It kicks off ethoxy group and it gives rise to corresponding cyclized compound with the loss of ethanol. This upon hydrolysis and decarboxylation, COET is lost, and when I treat this with zinc and amalgam, I'll get corresponding cyclopentane. This is Dickmann's condensation. Dickmann condensation is internal cyclization. This is a internal Claissen's condensation. Aromatic compounds, if I take and reduce it with hydrogen and nickel or hydrogen and platinum or hydrogen or palladium, in which the nickel or platinum or palladium are in finely divided state and heat it, the double bonds in the aromatic ring system gets reduced to give rise to cyclohexane. These are the four methods of preparation of cycloalkanes. In the next class, let us deal with the reactions of cycloalkanes. Till then, have a nice day. Thank you.